Dear students, in this video we are going to see chapter 2, the remainder theorem. What does it mean when the remainder is 0? You see here our dividend is 20, divisor is 4. So that here we get quotient 5, then 5 multiply 4 is 20, therefore remainder is 0. See, we can write this as 20 is equal to 4 multiply 5 plus 0. Here remainder is 0. So that we say that simply 4 is dividing 20 exactly, or we can say 4 divides 20 because the remainder is 0. In this first question remainder is 0. Okay, in other words we can say 20 is equal to a multiple of 4. You see here 20 is equal to 4 multiply 5. Here remainder is 0. So that here we say that 4 divides 20. Now you see the second question. 27 is the dividend, 5 is the divisor. Now the remainder is 2 as quotient is 5. Now we can write 27 as 5 multiply 5 plus 2. Okay, here we say that 5 does not divide 27, is not dividing exactly because the remainder is 2. See here the remainder is 2. Okay, so that we cannot write 27 as a multiple of 5. Okay, because remainder is 2. Okay, now you see we enter into the modulo, congruent modulo. How we read this? 31 congruent 25 modulo 3. Okay, now see how we can confirm that this given congruent modulo is true. How we can confirm that? Actually this is correct, but how we can confirm that? See, you take the first number 31 minus you take the second number 25, you find the difference, that is equal to 6. After writing 6, now you have to check whether it is possible to write 6 as a multiple of 3. Where is this 3? From where we get this 3? This is given in the congruent, that is modulo. See here modulo is 3. So now 2 multiply 3. See, is it possible to write 6 as a multiple of 3? Yes, we can write, because here if you write 2, then 2 multiply 3 is exactly 6, which means here your remainder is 0. Okay, in other way, see, I can make you understand. See, you take 6, then you divide by 3. Okay, then you get quotient 2. 2 multiply 3 is 6, your remainder is 0. Okay, see how to confirm this congruent is correct. How to confirm this congruent is correct, valid one. See, first you find the difference between these two numbers. Then for this difference value, see, for this number what you are getting here, you divide by 3. If you get the remainder is 0, then this is correct, congruent modulo, because 6 is exactly the multiple of 3. That's why we can conclude that this congruent is correct. Similarly, you see here 7 congruent 29 modulo 11. Same here. First you find the difference. 7 minus 29, that is minus 22. Find the difference. Then for this minus 22, you try to write the multiple of 11. Yes, here we can write 11 multiply minus 2. You can find this number minus 2. Here what is the remainder? 0. Actually no need to write here 0, but to make you understand I am writing. See exactly. See, I can write minus 22 as a product of these two numbers, minus 2 multiply 11, without any remainder, which means yes, this congruent modulo is correct. Okay, now you see I'm writing 31 is not congruent to 4 modulo 12. Actually this congruent is not correct. See, it is not correct congruent. Why? What is the reason? Now you see here, you find as usual you find the difference. 31 minus 4, that is equal to 27. Then you try, you see here 27 is equal to 2 multiply 12, 24. 24 plus 3 is 27. But here what is the remainder? Remainder is not 0. You get some number. okay, which means you cannot write 27 as a multiple of 12 exactly. Here you get some value remaining, that is remainder 3 here. That's why I say that this is not congruent modulo 12, that is here, okay, not congruent. Why? This is the reason. Okay, now you see another example. You see 7 congruent 5 modulo 2 and 5 congruent 3 modulo 2. Okay, actually why I put red line here, these two are correct congruent modulo. Okay, it is given. If these two are valid, then I can write, see, these two are valid. Yes, if you have doubt, you can check these two are valid. Okay, if these two are valid, by the property what I can write, see, I can combine this 7 and this 3, and then I can write the same modulo here. You see here 7 congruent 3 modulo 2. Again you can ask me, Mr. whether it is right or wrong. Yes, this is correct. That is a property. See, if these two congruent modulo is valid, then I can write, see, this first number and this number congruent modulo same value. See here modulo is 2, here also modulo 2. You write the same modulo. Definitely this is valid. If you have doubt, you can check. See the difference of 7 and 3. See, 7 minus 3 is 4. So 4 is nothing but you can write the multiple of 2. 2 multiply 2 plus remainder is 0. So this is correct. That's why I put. Actually, these are the examples from the properties what is given in your handouts. Okay. Now you see the second one. You see 12 congruent 2 modulo 5 and 8 congruent 3 modulo 5. These two congruents are correct. Yes. Yes, actually this is given correct one. Now, if these two congruents are correct, what I can do by the property, you take 12 and you take 8, you add these two values, see, that is 12 plus 8. Then here you see the number 2 and you see the number here 3. You can add these two values also, that is 2 plus 3 here. Then you put the same modulo. This is correct. By the property, this is also correct. By the property, this also valid. This congruent is also valid. You can check 12 plus 8, 20. 20 congruent 5 modulo 5. 20 congruent 5 means you will get the difference 15. Yes, 15 is exactly the multiple of 5. Yes, so that this is valid. Similarly, you can check. You see here this congruent is valid. Yes, 27 congruent 15 modulo 12. Yes, this is valid. This is given. Then by property, what you can do, you can multiply here any number. You see here with 27, you can multiply any number and you multiply the same number with 15. Then you apply this modulo. Then you apply this modulo. Then you apply this modulo. Again, you will get the correct modulo. That is by our property. So 3, see, I'm taking here 3. You can take any number. See, if I multiply by 3 in front of 27, you have to multiply by the same number here also. Okay, so that this is valid one by the property. Similarly, you can check this. See, these two congruent modulo is valid. Then see, you can multiply this 19 and 11. Okay, and you multiply 7 and 5 here and then apply the same congruent modulo. You see here modulo, you apply the same modulo, then this is also valid. Okay, by the property. Similarly, you can check this. See here 7 congruent 17 modulo 10 means this is valid. Actually this is valid, which means you can raise the degree both side. Here any number, any positive number. You see here you put 4 here, 4 here as a degree. See here 7 to the power 4 congruent 17 power 4 modulo 10. Yes, this is correct, valid. If you want to check, you can check in the calculator the value of 7 power 4, then value of 17 power 4, then you find the difference. Definitely that value is multiple of 10. Okay, it means exactly divides, then your remainder you will get 0 here. Okay, same here you can put, suppose here you want to change the number. Yes, you can put here 7 to the power, here you can put 25. Yes, no issue. Then 17 power 25, no issue. If you find, see the value of the 7 power 25 minus 17 power 25, then you check whether that is a multiple of 10. Yes, definitely that is a multiple of 10. Okay, this also valid. Whatever number you want, you can put in the degree. If this is valid, if this congruent modulo is valid one, then you can put any degree. Okay, whatever you want, but should be a positive number. Okay, now we will see all the congruent classes modulo 5 and write each class of the form as a set in two methods, in two ways. Okay, the first one is, see, the congruent classes modulo 5 in the predicate form. Okay, see here we are writing congruent classes modulo 5. Okay, first you had to understand that when you divide any number by 5, when you divide any number by 5, what are the remainders you will get? 0, 1, 2, 3, 4. Okay, so that now here you will get, for each remainder you can write the class. See, 0 class, 1 class, 2 class, 3 class, 4 class. Okay, so this is equal to nothing but, see, the set of all n belongs to z such that n is equal to, how you write this? You see here, n is nothing but, see here what you have, the remainder in 0 class. See here you are writing 0 class, so you write that value 0 plus 5 multiply k. What is k? K is some integer. See, k is some integer. What is k? Integer is nothing but z is equal to minus infinity, etc., minus 2, minus 1, 0, 1, 2, etc., infinity. This is called the set of all integers. So k is any value. K is any value from this set. Okay, so now similarly you can write the one class is nothing but n belongs to z such that n is equal to 1, this element we can say key element, plus 5 multiply k. Why we write here 5? Because we are doing congruent classes modulo 5, so you put 5 here, then k is any integer. Okay, similarly you can write until class 4. Okay, this is the predicate form. Now how to write the congruent class modulo 5 in the enumerated form? See, you have to list all the numbers. See here, 0 class, 1 class, 2 class, 3 class, 4 class, we know that, but how to write these numbers? Okay, you see here, first in 0 class you write the key element, that is 0 here in the middle, then you add, see right side, you add 5, which means plus 5, you add plus 5 with 0, then next plus 5 plus 5 plus 5, you will get all the numbers. Here when you write the values from the left of this 0, you add minus 5, 0 minus 5, then again minus 5, again minus 5, then you will get all the elements which is left side of this 0. Okay, this is one way. Another way is, you see here 0 class is equal to, see, n is equal to 0 plus 5k. See here k, you take the values of k from here, you substitute in this form, you will get, you see here k is 0, put k 0 5 times 0, you will get the first, see, center element 0. If you put k1, if you put k1 here, 5 into 1, 5. Okay, if you put k2, then 5 into, see, 5 into 2, 10. Okay, similarly you can write. See, for example, you take this class. See here, this is modulo class, modulo congruent class modulo 5. See here 3 class. Now key element is 3. To get right side values you add 5, to get left side values you subtract 5. Okay, in another way, how you see this, you see in the predicate form you have 3 plus 5k. Same, now you take the k values from here. You see, first put k 0, then 3 plus 0, 3 you will get here. If you put k1, then 3 plus 5 into 1, 5. So 3 plus 5, 8. You get the second one. Okay, in both ways you can find you can list the numbers of each class in the enumerated form. Okay, we will see the continuation of this video in another one.